So those who are online are able to hear me?
Yes, sir.
Okay. So look at this problem, try it out. So remember, not this Saturday, the following Saturday, there will be a test in this chapter. And mostly I'll ask only problems. Only problems and derivations is what I'm going to concentrate on. So make sure you're able to understand and get all your doubts clarified. And one more thing, I'm not able to speak loud. Okay, so please bear with me. You take that voice under. So okay. So just try this problem. So there is a 5 mega electron volt proton, which is falling vertically downward through a region of magnetic field 1.5 Tesla, acting horizontally from south to north. So again, in this question, what is the hint they have given? Acting horizontally, meaning a table. We have solved many problems based on considering the horizontal, no, a table. So it's the same logic. Find the magnitude and direction of the magnetic field exerted on the proton. Take the mass of the proton to be 1.6 into 10 power minus 27 kilogram. Try that out. There is only one formula, no? What is it? Just write the data first. And what is there? What is given there? 5 mega electron volt proton. What is the proton's mass charge? And then why are you taking 5 mega electron volt is the energy of it? I told you, look at the units, no, understand what quantity it is. So electron volt is a unit of energy. No charge. You go to the theory part. For radius itself, I would have given you 4 formulae. Actually, in this problem, let's see, charge is there. So charge is not given, but you still know it because it's a proton 1.6 into 10 power minus 19. Velocity, not known. Correct, Rani, correct. So what you need to do is you need to equate that energy to half mv square. Because what is unknown in this problem? V is not known to us. V should be found indirectly. Harini, are you clear? The face is blank. Clear or not? ஏதோ அப்படி இருக்கக்கூடாது. கிளியரா இல்லையா? எனக்கு அதுதான் வேணும். You know it? Do it. Half mv square is equal to அந்த எனர்ஜியை போடு. லெவன்த்லாம் படிச்சிங்களாடா? ஒர்க் எனர்ஜி தியரம்னு ஒன்று இருக்குமே, கேள்விப்பட்டிருக்கீங்களா? அப்படின்னு இருக்கு. ஏதோ இருக்கு சார். முன்னெல்லாம் அடிச்சிருந்தா உனக்கு உயிரை கொடுத்து சொல்லி கொடுத்தேன். ஞாபகம் இருக்கா இல்லையா? ஏதோ தெய்வமே தெரியுமா அப்படி என்ன? இல்ல நல்லா வருவீங்கடா. உனக்கு தெரியுமா ஒர்க் எனர்ஜி தியரம்? இப்படியா எல்லாம் போன கேஸா இருக்கீங்க எல்லாம். 1 minute. I have to take this call. அதுவே நீ கேளு. மெகானா எவ்வளோ? கம்ப்யூட்டர் சயின்ஸ் ஸ்டூடெண்ட்டா பயாலஜி ஸ்டூடெண்ட்? அதனால மன்னிக்க மாட்டேன். சொல்லு, அப்படியே சொல்லு. Let me check it. See, the energy of the proton is given. What is the energy of the proton? So 5 into, right? 5 into this mega is there, no? Mega is actually 10 power 6. Okay. I saw some of you didn't write the 10 power 6. Correct? And solar minus எதுக்கு ஆன்சர் இருக்காது. ஏன்னா this electron volt did you convert it to joule? (1.6 into 10 power minus 19 joule). This is equal to half mv square. M is 1.6 into 10 power minus 27 into v square. So that this 1.6 and 1.6 is gone. Right. So 2 will go to the other side. 10 into 10 power 6 into 10 power minus 19 is equal to, or you bring the 10 power minus 27 this side, it becomes 10 power 27 is equal to v square. So how much are you getting? 10 power 7 into 10 power 27, 10 power 34. 10 power 34 into 10 power minus 19 is 10 power 15. You told minus 15 or plus 15 now? Okay. So 10 power 15 is equal to v square, which implies v is equal to square root of 10 power 15, or it is square root of 10 into 10 power 7. Why is it so? Because 10 power 15 can be written as 10 into 10 power 14. So when you take square root on both sides, it is going to be like the square root of 10 into 10 power 14 is, the square root of 10 power 14 is 10 power 7. Right. So for those who don't know, write down this relation. 1 electron volt is 1.6 into 10 power minus 19 joule. 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Right. So these many meter per second. Am I clear with this point? Right. The next question is, if you observe, there is a magnetic field actually into the plane. Because when you take the table to be like this, right? So this is going to be the south to north direction. So it is into the plane. And how is the proton falling? It is falling in this way. So what is the angle between both? 90. So what is going to be the force experience? F will be equal to QEB. So what is the charge of a proton? 1.6 into 10 power minus 27. V is going to be square root of 10 into 10 power 7. Square root of 10 is, you can take that. Yeah, sorry, minus 19. So 1.6 into 10 power minus 19 into square root of 10 into 10 power 7. So square root of 10, you can approximate it to 3.3. So 3.3 into 10 power 7 multiplied with, what is the value of B? B is 1.5. So you can write it as 3 by 2 into sine of how much? 90. So sine 90 is 1. So all that you need to do is 0.8. 33 into 8 is how much? 24, 1, 250, 254. Yeah. So it will be 254, 1, 2, 2 decimals to the left into, you have a 3 also. So 3 into 10 power minus 12. So 254 into 3. 12, 6, 7. So 7.62 into 10 power minus 12 Newton. So 7.62 into 10 power minus 12 Newton. Let me check. Yeah. 7.56 is what they. Is the point clear? So there are two important takeaways from this problem. What are they? First is, you need to know mega is 10 power 6. So you can call it as mega or million also, because 1 million is also 10 power 6. Million is basically 10 lakhs. So 1 million is 10 power 6. And the second thing is electron volt in terms of joule is going to be 1.6 into 10 power minus 19. Okay. Shall I proceed? Oh, 2 is a carry, no? Yeah, 2.64. So 2.64 means how much are you getting? 2.64 into 3. 12, 9, 7.92, no? 7.92. The answer they've given is 7.58. It's okay, approximately. Right. Are you all copying it? But they ask the direction also. Right? So the correction that we have made here is 0.3 into 3.3 is 2.64. And 2.64 into 3 is going to be 7.92. And the next point that we need to calculate is the direction. So for direction, what are we supposed to do? Use a Fleming's left-hand rule. So field into the plane, current downwards. So this will be the force. So this is the direction of force. So force is acting in the east direction. Got it? Okay. Shall I proceed? Okay. Wait, I'll give you a better problem. Okay, now we'll try to combine both and see. Listen. So we'll see the next set of questions that are based on motion of charges in electric and magnetic fields. That is, we are going to apply the Lorentz force, which is going to be QE plus QEB sine theta, right? So what is the electric force on a charge? It is given by F is equal to QE. And what is the magnetic force on a charge? It is given as QEB sine theta. Am I clear with this? Right. So in a perpendicular magnetic field, what will happen? The charge follows a circular path. And what is going to be the radius of the circular path? It is MB divided by QB. And what is going to be the time period? Time period is 2 pi M by QB. And what is going to be the frequency? QB divided by 2 pi m. Right. Suppose it is not 0, 180 or 90, then the particle will follow a helical path, right? So when you talk about helical path, what is going to be the radius of it? R is equal to m into v perpendicular. So let me write it clearly. It is written as m into v perpendicular, which is going to be mv sin theta divided by qb. And what about the time period? Time period is still going to be 2 pi m divided by qb. And what is going to be an important parameter called as pitch? Pitch is the horizontal distance traveled by the particle in one complete revolution. So what is going to be the value? 2 pi mv cos theta divided by qb. Right? You know all these formulae. The next is kinetic energy gained by an electron when it is accelerated through a potential difference of V is given as half mv square is equal to ev, and this is energy conservation. Okay, so half mv square is equal to E into V. So from this, you can calculate the velocity using the formula root of 2 into small e into V divided by m, where E is the charge of the particle, V is the potential difference, capital V is the potential difference, m is the mass of the charged particle. So here the charged particle is basically electron. So instead of electron, if they give you some other charge, just put Q there. Is the point clear? So in this case, if you observe, the electric field is measured in terms of volt per meter or Newton per Coulomb, and magnetic field is measured in Tesla, velocity in meter per second, and radius in terms of meter. Okay. Now, having said this, shall we solve problems? So look at this problem. So an electron moving horizontally with a velocity of 4 into 10 power 4 meter per second enters the region of uniform magnetic field of 10 power minus 5 Tesla, acting vertically downward. It is acting into the plane, right? So what is the velocity of the electron? Velocity is going to be 4 into 10 power 4 meter per second. Enters a region of magnetic field of how much value? 10 power minus 5 Tesla, right? Which is acting vertically downward. Actually, it is into the plane. And what is the particle? It is going to be an electron, which is 1.6 into 10 power minus 19 Coulomb. Draw its trajectory and find out the time it takes to come out of the region of the magnetic field. So what is going to be the radius of the circular path? Since it is entering perpendicular to the magnetic field, what is going to be the radius? So R is equal to mv divided by qb. So what is m? 9.1 into 10 power minus 31 into what is the velocity? 4 into 10 power 4 divided by what is the value of q? It is 1.6 into 10 power minus 19 into what is the value of d? It is 10 power minus 5. Right. So 4 will cancel this 0.4 times. 91 divided by 4 into 10 power minus 27 into 10 power minus 24. It will go to the numerator. It is minus 24 going to the numerator. It becomes plus 24. So 91 by 4 is how much? 96 by 4 is, so how much is 91 by 4? Give it 2. You will have 11. So it is going to be 22.7 into 10 power minus 3. Right, 22.7 into 10 power minus 3 meter is going to be the radius. Is the point clear? Clear with this? So if you observe, 22.75 is going to be the radius. That's what we got to 22.7. Yeah. Now what will happen is, if you observe the trajectory of the particle, it will be like this. Okay. It will enter, take a turn, and then come back. Right? Because it will not be able to complete a full circle. Right. So because in the question itself, they have asked you, what is the time it takes to come out? So if you calculate the time it is going to take to come out, it needs to be a semicircular path. So when you talk about the semicircular path, how much is going to be the time? So time will be equal to 2 pi m divided by qb, the whole divided by 2. 2 and 2 will get cancelled. It will basically be pi m divided by qb. So when you calculate this, the answer will be 1.8 into 10 power minus 6 seconds. Okay. And this is the diagram they are expecting. So if it is going to complete a circle, it would have been inside one. It will take only, yeah. And it is not completing the circle, no? It is completing only semicircle. See, basically, distance divided by speed. So pi into r is mv divided by qb divided by v. V and v will get cancelled. Pi m divided by qb is the answer. Is the point clear? Right? Shall I proceed? Now look at this. An electron travels in a circular path of radius 20 centimeter in a magnetic field of 2 into 10 power minus 3 Tesla. Calculate the speed of the electron. What is the potential difference through which the electron must be accelerated to acquire the speed? Contra. So what is the answer? An electron travels in a circular path of radius 20 centimeter and a magnetic field of 2 into 10 power minus 3 Tesla. Calculate the speed of the electron. So R is equal to mb divided by qb. What is the mass of an electron? 9.1 into 10 power minus 31 kilogram. What is the speed? That is what you need to calculate. What is the charge of an electron? 1.6 into 10 power minus 19 coulomb. So radius is 20 centimeter, 20 into 10 power minus 2. Convert everything. Tell me what is the answer. 7.1. Which the speed? I have to check. Correct? So if you look at the solution of this problem, okay, listen. There is an electron that travels in a circular path. Right. So there is an electron that travels in a circular path of radius 20 centimeters, so 20 into 10 power minus 2 meter. And the magnetic field value is given as 2 into 10 power minus 3 Tesla. Calculate the speed of the electron. Right. R is equal to mv divided by qb, which implies 20 into 10 power minus 2 is equal to mass of the particle is going to be 9.1 into 10 power minus 31 into what is going to be the speed. That's what we need to calculate. The whole divided by q is how much? 1.6 into 10 power minus 19 into what is the value of b? 2 into 10 power minus 3. Right. So what will be the value of b? 20 into 10 power minus 2 into 2 into 10 power minus 3 divided by 9.1 into 10 power minus 31 into 1.6 into 10 power minus 19. So on solving this, how much is the answer we are getting? You will get the answer as 7 into 10 power 7 meter per second. Okay. On solving this, we should get the answer as 7 into 10 power 7 meter per second. Okay. Listen to this. What is the potential difference through which the electron must be accelerated to acquire the speed? What must be the potential difference through which this electron must be accelerated to attain the speed? For this, what we are going to apply is half mv square is equal to E into V, where V is going to be the potential difference. So half into what is going to be the mass of the particle? 9.1 into 10 power minus 31 into V square is 49 into 10 power 14. The whole divided by what is going to be the charge? It will be 1.6 into 10 power minus 19 is equal to how much? V. Right. So 1.6 and 9.1, can I approximately cancel it 6 times? Because 1.166 is 96. Approximately, I took it as 6 so that this will cancel this 3 times. So 3 into 49 is 50 into 3 is 150. 150 minus 3 is 147. So 147 into 10 power minus 31 into 10 power 14 is 10 power minus 17. So 10 power 19 will go to the numerator. It will become 10 power 2. Am I right? So 3, 10 power minus 13, 31 into 10 power 14 is 10 power minus 17. So 10 power minus 19 will go to the numerator. It will become 10 power 2 is equal to D. So V is equal to how much? 1.47 into 10 power 4 volt. So this should be the potential difference across which it should be accelerated. Right. So 1.47 into 10 power 4, or you can write it as 14.7 kilovolt. Both are accepted. Did you understand? Shall I proceed? See, this is again based on same question. Based on the same logic, no, let's try this. Those who are online are able to understand?
Yes, sir.
Okay. That is the meaning of horizontal and vertical component. So you basically have two formulae. Apply those two formulae, it will give you the answer directly. If you read the question carefully, the hint is there itself. Write down the data first. So what is the value of magnetic field? 0.02 Tesla. Travels in a helical path of radius 5 centimeters. So what is the formula for radius of a helical path? R is equal to MB. It is MB sin theta divided by QB. So V sin theta will be the perpendicular component. MV sin theta by QB, you know mass of proton 1.6 into 10 power minus 27. You know the charge of proton. You know the magnetic field. Just substitute, calculate the value, you will get the answer. இல்ல ரெக்கார்ட் நிறைய ரொம்ப ரொம்ப நேரமா அது ஃபேஸ் ரெகக்னைஸ் பண்ணலன்னா பிளர் ஆயிடும் அந்த மாதிரி அதெல்லாம் இருக்க ஜூம்ல இருந்து எடுத்து போட்டுறாங்க ஃபுல்லாவே பிளரா தான் இருக்கா எல்லா இடத்துலயும் இருக்கா ஓகே அது பிராண்ட் கலர்ஸ் யூஸ் பண்றாங்க அதுதான் அவங்ககிட்டயே பேசல Subscribe அது மாதிரி ஏதாவது. Yeah. So what is the answer for V sin theta? 1, 10 power 5. And what is the value of V parallel? Do you get this? 6.37 into 10 power 4. See, observe. So when we solve this problem, a proton projected in a magnetic field of value how much? 0.02 Tesla travels along a helical path, right? Of radius how much? 5 into 10 power minus 2 meter. And what is the pitch? Pitch is equal to 20 into 10 power minus 2 meter. Is it clear? So what is the formula for radius? R is equal to mv sin theta divided by qb. So v sin theta, leave it as it is. So which implies v sin theta is equal to qb into r divided by m. So what is the value of charge? 1.6 into 10 power minus 19. And what is the value of b? 0.0. So 2 into 10 power minus 2 into what is the value of r? 5 into 10 power minus 2, the whole divided by what is going to be the mass? 1.6 into 10 power minus 27. So 1.6 and 1.6 are gone, right? So this will be equal to 2 into 5 is 10. So 10 into 10 power minus 19 into 10 power minus 4 into this 10 power minus 27 will go to numerator as 10 power 27. So what is that you're going to get? 10 power minus 19 to 10 power minus 4 is 10 power minus 23. So 10 power 27 into 10 power 20 minus 23 is 10 power 4. So 10 into 10 power 4 is 10 power 5 meter per second. Is the point here? So 10 power 5 meter per second. Similarly, they have given us the pitch. So what is the formula for pitch? So pitch is equal to 2 pi mv cos theta, the whole divided by qb. So it is going to be 2 into 3.14 into what is the value of m? M is going to be 1.6 into 10 power minus 27, the whole divided by q is going to be 1.6 into 10 power minus 19 into 2 into 10 power minus 2. So b is 2 into 10 power minus 2. So 1.6 and 1.6 get cancelled. Right, 2 and 2 are gone. So what is that you're left out with? 2 pi m. Right. So this is gone into what is there? You have v cos theta here, and on the left hand side you have 20 into 10 power minus 2. Right. So what is going to be the value of v cos theta? So v cos theta will be equal to 2 into 10 power minus 1 divided by 3.14 into 10 power minus 27. 10 power minus 27 into this is going to be 10 power minus 19 into 10 power minus 2. Okay. So how much will the answer be? So how much is it going to be? So it will be, so 2 divided by 3.14 will be 0.63 into, this is going to be how much? 10 power minus 19 into 10 power minus 3. It is 10 power minus 22. So 10 power minus 27 will go to the numerator. It will become 10 power minus 22 into 10 power minus 27. sorry, plus 27. So answer will be 0.63 into 10 power 5, or it is 63 into 10 power 3 meter per second. So it is 63 into 10 power 3 meter per second. Is the point clear? Clear? Shall I proceed? So cyclotron is deleted. Don't need cyclotron. So the next set of problems that we are going to see is, so next we'll see the set of problems that are based on force experienced by a current carrying conductor placed in magnetic field, which is given by the expression I into L vector cross B vector, or it is also written as ILB sin theta. And what is going to be the maximum force that will act on the particle? Maximum force is possible when the value of theta is equal to 90 degrees. So maximum value of force is possible when the value of theta is equal to 90. Okay. So did you all make a note of it? So try this problem. Okay. So this one. Try this. A wire of length L carries a current I along the x-axis. A magnetic field of this much value exists in space. Find the magnitude and magnitude of the magnetic force on the wire. What is the answer? Yeah. Why 0? What is the direction of current? I BL. B a B not a. F is equal to I into L vector cross B vector. Correct. So what is the value of I only? What is the value of L vector? It is L I cap cross what is the value of B vector? It is B naught into, right? So F vector is equal to I into L vector cross B vector. So I into L I cap cross B naught into I cap plus J cap plus K cap. Is the point clear? So what will happen in this case? It will be IL into B naught into I cross I is 0. Plus what is I cross J? It is K cap. Plus what is I cross K? Plus minus J cap. Listen, why is it so? I've told this already. This is I, J, K. I cross J, anything anti-clockwise is positive. So I cross J is K. J cross K is I. K cross I is J. Anything clockwise, so this is positive. Anything clockwise is going to be negative. I cross K is negative. Right? So it will be B naught I into L into K cap minus J cap, which is going to be the force. So this is the force in the vector form. Right? So when you want to find the magnitude, that's what they asked. No, magnitude of force is going to be equal to B naught into I into L into square root of 1 square plus 1 square. Answer will be root 2 times B naught I into L. So it is root 2 times B naught I into L. Okay. Clear? So root 2 times B naught I into L. Right. So I'll do one last problem. So look at this problem. The horizontal component of Earth's magnetic field at a certain place is given by, so BH refers to horizontal magnetic field, is going to be equal to 3 into 10 power minus 5 Tesla. And the direction of the field is from geographic south to geographic north, south to north. In this case, you take it vertically. A very long straight current carrying conductor is carrying a steady current of I ampere. What is the force per unit length on it when it is placed on a horizontal table and the direction of current is east to west, and when the direction of current is south to north? Okay. So on the horizontal table, this is where the tricky part is. Listen to this very carefully. On the horizontal table, this is east, west, north, south. Whereas when they talk about the geographic north and geographic south, this is the geographic north, this is the geographic south. So there are two fields coming here. Are you able to understand this point? Okay, this is where you need to be careful. So this horizontal magnetic field is from geographic south to geographic north. A very long straight current carrying conductor. That is why you cannot find the force directly, because it's a long conductor. You can find the force only if you know the length of the portion. So what is the force formula? F is equal to BIL sin theta. So what is the value of magnetic field which is acting on the particle? So 3 into 10 power minus 5. That is acting on the conductor is 3 into 10 power minus 5. What is the current? There is a I itself. I think it is 1. So let me take it as 1 and then solve. Okay. So 1 ampere. And what is going to be the value of length? What is the force acting per unit length? So I don't know what is the value of length. I'll take it as L itself. But what is the angle between the magnetic field and the direction of current? When the current is flowing from east to west. So what should be the answer? I doubt. Sorry. 3 into 10 power minus 5 will be equal to the amount of force per unit length. So those many Newton per meter should be the answer. Right? I think I made a mistake. 1 minute. Yeah, it's my mistake. I'm sorry. It was because when they told about the geographic north and geographic south, right? I missed this word. It is a horizontal component. So this is the one. So first one is correct. Answer, this is correct. Force per unit length is 3 into 10 power minus 5. But for the second one, when the current is flowing from south to north, what is the angle between the magnetic field and the current? 0. Actually, this is wrong. I'm correcting myself. I want everybody to listen. Okay. So what I'm trying to say is, if you take this to be the table, this is east, this is west. So this is south, this is north. No, this is the horizontal component itself. So what is happening in the first case? The current is flowing perpendicular to it. In the second case, the current is flowing in the direction. So in the second case, the force is 0, whereas in the first case, it should be 3 into 10 power minus 5. Let me check it. Yeah. So 3 into 10 power minus 5 Newton per meter. So I hope there is no confusion. Did you understand? So don't draw this one. This is wrong. So did you understand why in this problem they are not asking you the force, but asking only force per unit length? Why is it so? Generally, when they say long conductor, the length is not known. So force per unit length will be on some small portion that is there. Okay. So one set of problems, not one set, two set of problems that we are supposed to see is torque and galvanometer. Okay. So the torque and but these problems, it's again the same thing. Only one formula, BAL sin theta, BAL sin theta. Only thing is diagram should be proper. Same is the case with respect to torque also. The only challenge will come when you deal with galvanometers. So that one will be the last concept I'm going to discuss on. Last set of problems I'll discuss on Monday. With that, it will be closed. And the following Saturday, not this Saturday, the following Saturday, you will have a test in this chapter for 35 marks. Is the point clear? So date and everything will be announced. So make a note of it. Who is entering in the register there? Yeah. So the test about the okay. So is it clear? So any other questions? So not well, actually, sorry, I could not solve many problems. Energy levels are down. Okay. So please revise these things. Those are online. I hope you could understand.
Yes, sir.
Yes, sir.
Yeah. So I'll see you guys on Monday. Just keep practicing, okay?
Okay, sir. Thank
Okay,
you, sir.
sir.
Yeah.
Thank you, sir.
Thank you. Weber per meter square Tesla. Weber is the unit of flux, magnetic flux. Weber per meter square Tesla. Same as calculation.